everyone, welcome to virtual lesson 10, log properties. We are going to work on expanding them today, which is the opposite of condensing or combining. So instead of putting them together, we're going to be pulling them apart. Here are the log properties we had talked about last week. Basically what we're going to focus on today is if two things are being multiplied inside, they're going to get added as their own separate logarithm with the same base. If they are being divided, they are going to get subtracted as their own separate logarithm with the same base. And basically the difference is anything that is being divided or is in the denominator gets a minus instead of a plus in front of it. And then anything that has a power, that power is going to go out front and it's going to stay there. So we don't want anything with a power left inside, and we want there to be one thing in each log, not two that are either being multiplied or divided like this. And that can be numbers or it can be a variable. So it can be a number, it can be a variable, not both, and it shouldn't have any powers. So here's our first example. It's going to say expand each logarithm completely. What we're going to do is look and see, well, there's a 7, an x cubed, and a y squared. And they are all being multiplied because we can't see anything in between them. That means multiplication. Since they're being multiplied, that means we're going to give them each their own separate log base 5 and add in between all of them. Okay, so last lesson, we multiplied these two and made it one log like that. Now we're just doing the opposite direction and taking it apart instead of putting it together. Then both of these powers that the x and the y have, those are going to go out front. That's pretty much it. That's the answer right there. Because you'll notice that each log has either a number or a variable, not both, and the powers have already been put out front. That's pretty much it. Here's example 2. You'll notice that the y to the 7th is on the bottom. And that means it's being divided, so it's going to get subtracted instead of added. But the 9 and the x to the 4th are still being added because they're being multiplied up here. The only things that get subtracted are things that are in the denominator. One thing I'm going to stop and say about this really quick is you'll notice that there's no base, no subscript right here. That means it's 10. This is just common log, that means it's a base 10. If it's ln, then it would be base e. Everything else besides 10 and e have their own numbers down there. Okay? Then I need to deal with my exponents afterwards like I did in the last one. So this 4 and this 7 are going to go out front. And that's my answer. Because you will notice that each log has either a number or a variable, not both, and don't have powers left because we put them out front already. Okay, example 3, I chose this one because it has a square root. First of all, this is the natural log base e. If you're curious why it says ln instead of log, that L and the N stand for natural log. And then what we're going to do first on this one is deal with that square root. Keep in mind that the square root is the 1/2 power. That means we're going to separate them all. They're being multiplied, so we're going to add, and we're going to put a 1/2 power in front of all of them. So they would all get a power of 1/2. Instead of writing it, I just put the 1/2 out front already, automatically. Now, one thing really quick. If not all 3 of these were underneath, only the ones that are underneath the square root get the 1/2 out front. So let's say this y to the 5th wasn't underneath, then we would just get rid of this one, but the other 2 would still have it. Okay? Then the x and the y still have exponents, so we're going to put those out front, but when they come out front, this 3 is going to multiply by 1/2 and become 3/2. And the 5 is going to multiply by the 1/2 and become 5/2. Okay, and that's pretty much it, because now every log has a number or a variable, not both, and no powers. That was a little quick. Let's move on to example 4 in just a second, in case somebody's writing that one down. Now, what this one should really say at the top is expand each logarithm completely and simplify. And I did that on your guys' homework for you because what's going to happen is these two are being divided, so we're going to subtract them. x to the 6th, and 100. And we're going to try and simplify. I can't simplify this because there's no power of 10, which is the base since there isn't a number right there, that's going to give me x to the 6th. At least not until I know what x is. Over here, though, I can put that little power or base of 10, subscript of 10, and ask myself what power of 10 gets me 100. And I'll tell you to simplify so you know when to look for this. Well, what power of 10 gets us 100? 2. So this is really just log of x to the 6th power minus 2. And then the ln is actually base e. So after I separate these into 8 and e to the 4th with addition, because they're being multiplied, I'm going to come over here and say, okay, well, the base of ln, or the natural log, is e. What power of e gives me e to the 4th? Well, 4. E to the 4th power is e to the 4th power. There you have it. I cannot do the natural log of 8 because it's not a nice number, so I'd rather just leave it as the natural log of 8. If it doesn't end up being a whole number, just leave it, unless I say evaluate and round. Okay, and I did not say that on me. All right, we have 2 examples left. What they are both going to do is we are going to simplify first and then expand. So what you're going to notice is there's a square root, but there's stuff on top and bottom. And we can actually divide these 2 numbers. And these are both x's. And what do we do with exponents when we're dividing? Subtract. So I'm going to do 98 divided by 2, which is 49, and 7 minus 2, which is 5. I haven't done anything with the square root or the log base 3 yet. Now I'm going to actually do the square root because I can do the square root of 49. It's 7. And then I'm going to add because these are being multiplied. And notice how the x has still got the 1/2 out front because we can't actually do the square root of that. We can simplify it if we want to, but please don't. It gets really confusing if you do, because then you're going to have 2 separate logs with x's in them and it looks kind of confusing. But what I can do is bring this 5 out front to be with the 1/2 and make it 5 halves instead of 1/2. And that's it for that problem. Okay. What we're going to do now is combine the logarithms and then simplify by expanding. What I mean by that is it's going to start off with 2 logs. In order to simplify this, we're going to put them together and then bring them back apart again. Hey, I know that seems a little silly, but like sometimes we have to multiply 2 things together so that we can add something in and then refactor it. That's kind of like that. You might not know what I'm talking about, and that's fine if you don't. But what ends up happening is, since these are being subtracted, we're going to divide 48x to the 5th by 3x cubed. And it's going to keep the base 4 in there. Well, 48 divided by 3 is 16. When we divide, we subtract these 2 exponents. 5 minus 3 is 2. And now I can separate the log into log base 4 of 16 and log base 4 of x squared, adding because these are being multiplied. And over here, what power of 4 gives us 16? 2. And then the x squared, that 2 from the x squared is going to come out front here. And that's it. And we couldn't have gotten here if we hadn't combined those first and then separated them. And the directions are going to say, combine the logarithms, then simplify by expanding. Sorry, didn't mean to hit the arrow. And this should technically be example 7, by the way.